Hi, I'm Michelle Segrest, and welcome to the Factory of the Future podcast.
This podcast is inspired by my 3-volume book series on the evolution of modern manufacturing. Each episode features engaging conversations with game-changing experts discussing the processes and innovations that are changing the landscape of modern manufacturing. Thank you so much for listening. Please do me a favor and leave me a 5-star rating on iTunes, and take just a couple of seconds to leave a review. And then go ahead and hit that subscribe button right now so you don't miss a single episode. I am really excited to have 2 very cool guests today to discuss the need for and the evolution of warehouse digitalization. Efficiency is key in manufacturing, as you all know, and logistics and understanding of real-time location and operation of all assets allows better planning and more efficient operations. One significant challenge today is how manually guided vehicles like forklifts can be cost-effectively tracked and integrated with autonomous vehicles in logistics and manufacturing environments. Adding visual SLAM to manually controlled vehicles allows this to happen in dynamic real-world environments. And we're going to talk about what we mean by visual SLAM. SLAMcore and SYNAOS have partnered to create SYNA.OS View, a low-cost, real-time spatial intelligence system for manually guided intralogistics vehicles. What we're talking about here are forklifts and warehouse vehicles. And today I'll be welcoming in Owen Nicholson, who's the CEO of SLAMcore, and Tobias Gagern, who is the CTO of SYNAOS. Both Owen and Toby have extensive experience and have conducted significant amounts of research in the areas of how robotics and automation can help manufacturing. SLAMcore's mission is to make quality spatial intelligence available to everyone. Its team of world-leading spatial intelligence experts have developed SLAM algorithms that allow robots, drones, and machines to fully understand the space around them. SLAMcore pushes the boundaries of what's possible today and what SLAM and perception will look like tomorrow. This means that their algorithms for robots and machines help them understand where they are and what's around them in an affordable way. SYNAOS works with some of the largest manufacturing factories. Its software calculates 250,000 solutions per second without a break. This is possible with the computing power from the cloud, which also makes immediate software updates possible. Many manufacturer-dependent systems still cannot be scaled sufficiently. Dusty system architectures block important innovations. The overall system remains opaque, which makes the increasing complexity a problem. SYNAOS has resolved this issue, and we're going to talk about that today. First, I want to tell you a little bit about Owen and Toby. Owen Nicholson is the CEO and co-founder of SLAMcore. He has over a decade of experience in early-stage R&D management, working on both UK government and industrial-funded research portfolios. He has successfully delivered technologies in a wide range of fields, including UK Special Forces, next-generation nuclear submarines, and domestic electronics. Previously, he spent 4 years building and managing the university research program for a leading global engineering company, transferring technologies from top research institutions around the world. He specializes in the strategic and commercial aspects of technology development and acts as an advisor to the UK government on university technology transfer. Toby is CTO and co-founder of SYNAOS. With his co-founders, he gained years of experience in the automotive industry as well as in the IT environment. This valuable know-how now flows fully into SYNAOS. Now, these guys got together and joined forces and took their own expertise in areas of specialty and really created a cool solution for warehouse digitalization. And that's what we're going to talk about today. So let's get into it. Owen and Toby, welcome to the podcast.
Thanks for having us, Michelle.
Hey, Michelle. Great to be here.
So I want to talk about this solution that you guys created. But first, let's talk about the problem. I understand that 99% of warehouse processes are still driven by forklift. And I was kind of surprised by that stat when you guys told me that. But it makes sense that warehouses need more digitalization. What I want to know is how you guys got together and decided that this, first of all, was an important problem to tackle, and then how you use your unique areas of expertise to accomplish creating a solution. Toby, you want to start?
Sure, I can start. I think it was actually a long journey until I met Owen, because we actually started with the general planning problem in warehouses and logistics. So how can you use artificial intelligence to make existing processes much more efficient? But of course, when it comes to efficient planning, you need good system feedback and good data to allow a process to be optimized to the limit. And then you stumble into the next problem, that you need a platform to integrate all of those processes. And that was something that we have been working on for quite a while. So the optimization and the integration. But we always reached this point with we're good at integrating robots, integrating autonomous guided vehicles. But the forklifts were always like old school hardware, where we couldn't get any information out of them. So, for example, we were really interested in their position, and we thought about, okay, how can we get this data, the positioning data of the vehicles, so that we can consider them in our AI algorithms and so forth. And then we looked for a solution. How can we get a proper position out of a vehicle? And there's a lot of technology out there, like ultra wideband or LiDAR sensors and so forth, but they were all quite expensive. Then we since I'm coming from the automotive industry, we thought about, okay, what are other solutions to get positions? And then it was pretty clear for us, cameras, because cameras are a low-cost sensor, and all the intelligence is basically in the software, which scales much better than putting a lot of hardware within the facility. So we then went down that route, and we looked into different algorithmic approaches. And then you sometimes say, okay, this is the technology we want to use. And then you reach a make or buy decision. And we said, okay, we do not want to make that on our own. We need a partner for this. And then the good old Google search led us basically to SLAMcore.
You can always count on Google.
Yeah, of course. And
good to hear our SEO's working.
And then we looked, of course, into different solution providers, and then we started the conversation with SLAMcore.
Okay, so enter SLAMcore. So Owen, you pick up from here and tell us how you became involved.
Absolutely. So we positioned ourselves in the market as the real world leading experts in using cameras and vision-based technology for positioning machines and helping them to understand that space. And we've been doing this for nearly 5 years now. Our roots are in the coming more from the consumer electronics space. So I spent a lot of time working on vacuum cleaners, and my CTO as well was also worked in for vacuum cleaning robotics technologies. So we know a lot about how to use cameras and low cost hardware for positioning in 3D space. And we've been building that product over a number of years. We have a number of customers at the moment, but we received essentially an inbound request from Toby and the team saying, we have a really clear problem here right now, and we believe the technology is a good fit for what our customers' needs. And as we automatically realized this was something we could serve well, and jumped on a call and started to explore exactly what the detail might look like as we start to try and actually understand the real problem and how we go about solving it. And after a number of discussions, a number of thoughts around the way in which we can actually build such a solution, we decided, okay, let's go for this and build a POC. And really from then on, it's been a really quick journey as we've been able to integrate the software into a solution. And yeah, very excited to have this now available onto the market.
Fantastic. So I have a question that may be a stupid question, but I feel the need to ask it anyway. So, as I said before, that 99% of warehouse processes are still driven by forklift. Why is that a problem? Why do we need digitalization on forklifts?
There are a few interesting aspects. If you look at the supply chain optimization today, we talk a lot about trucks and ships and whatever, and that we have to track them. And we see it at the moment in the coronavirus or with the Suez Channel disaster. We immediately see when the trucks or the ships are not coming anymore. The problem is there are also harbors and warehouses in between. And a lot of efficiency gains and digitalization is happening on the street, but not a lot is actually happening within a warehouse. And just give you a number. So the warehouses are becoming a more and more bigger problem. For example, the number of truck drivers in the US in the last 10 years rose by 12%. The number of warehouse workers rose by 226%. So we can immediately see where the next big bottleneck in our supply chain is coming up. At the moment, those warehouses are heavily reliant on manual planning, no data integration, and no software assistance actually to make those processes more efficient. And that's why I think we can still drive with manual forklifts, but we have to increase the efficiency a lot to meet the new customer demands with shorter lead times, higher fluctuation, and so forth. And that's why we really have to think about, okay, what can we from a software side bring to the market to make those processes much more efficient? Because I think that the challenges in the market are already pretty significant.
Yeah, what do you have to add to that, Owen?
So it's a really interesting problem space that we have been working in for quite a while, because our technology initially was designed for robots and autonomous systems. So actually looking to help machines navigate through space and effectively move things around. And there is a real explosion in autonomous systems within the warehouse industry. We have a number of customers using our technology to move things around the warehouse and the manufacturing plants in an autonomous way. You just have to look at the Amazon and Alibaba warehouses out there now. They have a huge amount of robots. But as we said at the start, actually most of the warehouse companies out there are not the Amazons and they're not the Alibabas. They have much more manual processes and they're not able to instrument up the entire warehouses in a way which will allow you to have fully autonomous systems running 24/7. And that means we need to come up with a solution which allows the two systems to work together well, so that we can make sure that we are optimizing the operations that need to happen within that warehouse to essentially get as much as you can out of the assets you have. The challenge is, our technology is really there to help the warehouse owner and help the owners of those operation plants really to make sure that they, with the assets they have, make sure they use them in the most efficient way possible. Having a really clear understanding of where everything is in real time will help you schedule the jobs that need to be done in a much more efficient way. So this technology is all about making sure that at the kind of level of the warehouse that you can do as much as you possibly can with the assets you have available to you. Because as Toby said, we are really struggling, particularly in the UK right now. We have a massive crisis right now in being able to move things around our warehouses, get them out of the ports and get them into people's homes. So one way of helping with that is to introduce more automation and have more robots in the factories, but that's just not possible for many of the companies out there. So then what you can do is make sure that the assets you do have are used as efficiently as possible and you don't have downtime. And that's really where I think this comes in.
Right. That makes a lot of sense. You're able to collect data. Can you give me an example of the kind of data that you can collect using this solution and why it's important to have that data?
I can give you an example. I think the cool thing is with this solution that we bring to the market with SLAMcore and our existing software solution, SYNA.OS Logistics, which is an intralogistics operating system, we can actually close the loop from high-level warehouse orders to fully tracked, monitored execution on the shop floor level. What do I mean by that? So, for example, a transportation order comes into your warehouse, and you have different system which could execute this transportation order, or it's often not only one order that comes in, but you might have thousands of orders that are streaming into your warehouse. E-commerce company, all the time people are ordering on your website. Then we are able to, with our AI-based planning algorithms, to react very, very quickly to those incoming orders and plan them much more efficient than, for example, current algorithmic solutions can do that. So we can reduce actually the number, just by the planning algorithms, of for example, the number of forklifts that you need to execute an order pool by 30% compared to other solutions. The problem to do that, or to leverage this advantage of advanced AI algorithms on a planning level, is we need system feedback for that. So, for example, if I now assign an order to a forklift and say, and we do that very precise, by the way, we say, okay, you start at 12:01 and you are supposed to be ready at 12:05 with this particular order. We can track this vehicle right in between and can already see, while it's moving, okay, he will not finish this order at 12:05. It will be most likely 12:07. Those 2 minutes delay, I can immediately feedback into our planning system, and the next order that he has to do, I can reschedule that to another vehicle, because now another vehicle is a better or a more optimal vehicle for the overall order pool. And we do this basically 250,000 times per second, always trying new solutions putting new events in there, but you need this feedback from the shop floor. That is really important to see, okay, who is doing what at which time, that you can react much faster to unforeseen events, for example.
You have some sort of device on the forklift, a camera, sophisticated device, right? And that feeds data back to a software program that then runs the data. Is that how that works? Or help me understand that.
Absolutely. Let me talk you through a bit of from how the data flows from the camera to the kind of the central server. So, and what I think is really exciting about the SYNAOS and SLAMcore working together is we have our own kind of core expertise in AI, but they're actually applied in almost at different ends of the problem. So our AI is an edge solution which runs on the actual machine, on the forklift itself, running there using as low powered silicon as we possibly can. We can run on, say, a Raspberry Pi or less, and then we pass the output of our information through to the centralized server, either in the cloud or on the premises of the warehouse, where the SYNAOS AI takes over and does all of its amazing things Toby was just talking about. Mm-hmm. But it's important. You cannot have a system which is piping around just camera data from every single forklift. It would be too much data. We're talking gigabytes a minute, and it would just crash the entire Wi-Fi connection in the warehouse. So what's really important is that our software, this is where SLAMcore Edge software comes in, and really one of our core expertise is extracting the important information from the camera that is on that forklift and turning it into no longer just images, turning it into positional information. So we only need to stream 6 numbers, which is your X, your Y, and your Z, which is the coordinates, and also the orientation across those axes, which is called your 6 degrees of freedom and position. So all we're doing, the only data that's traveling from the forklift to the central server is 6 numbers, and so it's very, very low bandwidth. It can happen very quickly. But the kind of the secret sauce, and we can go into a bit more detail about what's going on under the hood there in the translation of the camera data into those 6 numbers. That's the part of the puzzle that SLAMcore bring to the table here.
The data that comes in, do your 2 companies analyze that data and go back to the customer, or do you train the people in the factory to use this system and to analyze the data?
Actually, the monitoring, so Owen said it perfectly, like we only actually care about the position data, so about those 6 numbers that the device is providing to us. The monitoring and analysis of this is fully automated on the SYNAOS side. So we track the progression of each order of each vehicle and generate, based on that data, events, like, for example, delays. Okay, I expect this vehicle to be a minute delayed because I can already see that he should have reached that point by this time, but I don't know, he took a coffee in between, or it just took a little bit longer. Based on that data, we can provide a wide variety of different use cases. We are basically we are good in cloud software and backend software to analyze this data, and that's why it's basically a match made in heaven. Owen and the guys with their expertise are really good in generating that data on the shop floor, and we are really good into transforming it, monitoring it, and using it for efficient process control within the backend. Yeah, that's basically the secret of the sauce.
Yes, that makes perfect sense. And I want to get a little bit of a history here. So how long did it take you guys to create this solution together, and how long has it been in the market?
The development of the core technology, I think, from both of us has been happening since really we started the companies many years ago. It's just we intersected the 2 technologies really towards the start of this year, and really starting working on it over summer. So one of the real strengths that we have as a company is we are able to build these systems and help and integrate them in a very, very short amount of time. So traditionally, building a system based on vision in this way could take years. You could need an entire team, PhDs, to even get the thing up and running. Well, luckily, we've done that. We have 30 staff, 15 of them have got doctorates, and we're growing every day. So it means we can actually start to integrate and build a full solution very, very quickly. But interestingly, we're a software provider ourselves, and obviously we're not the warehouses and forklifts are physical, real. They exist in the real world. So there has to be a point at which this software gets put into something physical, into the hardware, and that's where a lot of the work was around. So working with SYNAOS to understand what's the right hardware that we need to put. How do we make this really easy for the user, but also how do we make sure that the hardware itself isn't a price barrier to allow this to happen? Because ultimately, every single system forklift is going to need this box, this piece of hardware on it, and we have to. So making sure that was all self-contained, really simple and easy to use, and also affordable. That was a big part of the work.
Yeah, I was surprised when you said this year. I expected you to say 5 years or something like that. I was really surprised that
it's under 12 months. I would say it was under 12 months. So,
under 12 months, yeah.
Yeah, we had basically pretty clear specifications what we wanted to achieve right from the get-go. Like Owen said, we wanted to make it at least 10x cheaper from a hardware perspective than other solutions on the market. And on the other thing is we wanted to make it easy to integrate. We knew that, for example, when you have other localization systems like LiDARs, you have to record a map, then this map has to be cleaned, and it might take months or weeks to set those systems up. And we wanted something that is way more robust, where you can basically change your environment around without having to recalibrate or create new maps. We didn't want to have a mapping process in the beginning. And that were basically the boundaries of the vision that we wanted to work in. And I think within a year, we were able to get the first pre-production and now production devices to the market.
Well, how long does it take to go into a factory and set the company up with this solution? Is it like in a day? Like can you go in the morning and in the afternoon they're up running?
Yes. Actually, we have examples where we did it in 2 hours. Because we basically, SLAMcore, Owen, you can explain it much better than I can, but I give it a try. So what we actually do is that we basically track the relative position of the device, right? How is it changing from one frame to the next frame in the video stream? So we can basically decide, okay, how was my relative movement? But we have to just get a global reference point, and that is something that we do with QR markers. So what you basically have to do is that you put a QR marker every 150 meters, just pin it on the wall, give us the position of that one, and then we can then just drive in between. So if you have a large warehouse, you can put in 5 to 10 of those markers, depending on how accurate you need it. Normally you have a floor plan of that warehouse. You know where you put it into the system, and then you're already good to go.
So in the morning, you can retrofit a factory with this technology, and in the afternoon, they can be looking at data.
Absolutely.
Yeah,
that's amazing.
In the cloud, accessible from everywhere.
That's unbelievable. And so what kind of feedback are you getting from your customers?
The feedback that we are getting is a little bit like an iPhone experience, because what was so new about the iPhone, it was actually having internet and connectivity, and the second is they had a GPS system in there, so you get the position. And once you bring that capability also to a forklift, you can often see the sparkles in there and say, okay, now we can do this use case, now we can do this use case, now we can do this use case. So they understand the technology pretty quickly once they see basically a dot on a screen driving in their facility, and they say, okay, we can get rid of scans because we know where the vehicle is, so we do not have to scan this and that. Or we can, for example, we always had the problem that when we introduced, for example, mobile robots into our facility, and then the forklift drivers always had to drive really carefully so do not crash into that robot. But now I basically know where the forklift is, and I can tell the robot beforehand, okay, don't turn the corner. A forklift is coming. So we basically flip everything on their head. Before the humans had to take care of the robot. And now basically, because I know where the human is, I can start tracking the robot and tell him, okay, stop, let the forklift drive through, and then you can go next.
So it's traffic control. It's traffic control, yeah.
It's everything. It's like what we also saw is like you want to see utilization. So where are we actually driving most of the time? Is my warehouse set up correctly? So why are most of my pickups in the top right corner and brought to the bottom left corner? Maybe I should put all the goods that are in the top right corner into the bottom left corner so I can minimize traffic. So there's like multiple of use cases where you actually need this data to achieve a new performance level.
Very, very interesting. You guys said something, I can't remember who said it, but I want to come back to it. So you talked about the big guys like Amazon, the Amazons of the world. They have this kind of digitalization in their warehouse. They have to for the volume that they take care of daily. But I want to talk about smaller companies. Can a small company that doesn't have a huge budget or doesn't have a lot of digitalization sophistication yet, can they take one of these and put it on one forklift and make a difference in their facility?
It depends on the underlying use case, but absolutely, because we have a rental model basically, which already allows you to get in on a really cheap, on a low budget side. And
Good.
with that, you can, of course, start getting this technology into your warehouse pretty quickly on a pretty low budget.
This is something I think is really interesting from a kind of a macro industrial perspective, because we do have in this logistics space, we have some absolute giants out there who are dominating the space, and it's very hard for the smaller companies to provide and fulfillment at a cost which competes with these giants. But actually, when you look at the industry, the vast majority, probably 90% of it, is made up of these smaller companies. As big as the Amazons and Alibabas are, actually, most of the companies are smaller, medium-sized companies who are looking to find ways in which they can improve the efficiency of their operations. One of the benefits of being a giant is you can just go in, you can buy an entire factory, you can fit it out, you can do everything you want. But I think for the smaller companies, the only way we can compete, and we know this very well as startups, is we have two superpowers, and it's speed and flexibility. And that's how, as an industry, we're able to compete and provide solutions which do compete with these giants, because we can be much more flexible, much more agile, and choose one, like you said, just do one and grow from there. And we can also move extraordinarily quickly because we don't have as much bureaucracy. That's why we're able to deliver something like this in such a short amount of time. And I think what's particularly exciting about this product is the nature of the technology is it's empowering the customers to be very flexible and agile as well. So all the way down, so SLAM itself stands, like the SLAM in SLAMcore is an acronym that stands for simultaneous localization and mapping. So the reason why it works out of the box is you can turn it on anywhere where it's never been before, and it can start generating position data even though it's never been there before. And then all the way up to the AI that comes from SYNAOS, which is all about scheduling your system to be efficient and flexible and help you get as much as you can out of that system. So it's a really interesting dynamic, and I think this is something which is going to be really well. It already is being really well received, and it allows us all to do a lot more with less ultimately, or do more with the same amount.
Exactly. And the other thing is that we, especially for the small and medium-sized enterprises, everything that you can get from us, you can basically get on a software as a service package base. So you do not need your own IT infrastructure. We basically take care of that for you, because often we see that when you're a warehouse operator, you do not have like 5 people standing in your IT department that can take over the daily operations for those kind of applications. But I think with modern cloud technology, we can take care of this side for you. We have the experts, and we are up to 92 people now, and we can host the whole environment for you, and you basically just benefit from the data and the operational excellence that we can also bring to smaller fleet sizes with a quick cloud deployment, so they just consume the service without all the operation hustle behind it.
That's a really nice feature. And so when you analyze the data for a company, say that they do want that full service package where you also analyze the data, do you actually come to them with, hey, this data showed us this and you could fix it this way? Do you give them solutions based on what the data tells you, or do you just give them the data?
We actually do both. So the first thing is that we of course, it's their data. We do not own that data. It's their data, and they can have it afterwards without any problem. So what we normally do is come into the customer side, do a 2 to 3 months trial period, for example, where we collect a lot of data. We analyze it in the cloud and give you, for example, performance indicators like how heat maps, where you're driving, and so forth. At the same side, if you also provide us with the orders that you're putting through your system, we can also make a simulation and tell you, okay, at the moment you need, for example, we have real-world customer examples where they were running with 21 forklifts, and we actually said, okay, we can bring that down to 11. For the same order pool, same delivery times, we were nearly able to cut the amount of needed forklifts by 50%. And I think this is quite significant savings that we can generate with the full ecosystem. But we start with the data acquisition, make a first analysis, then we can enrich that data with, for example, order flow and so forth, and then we can get into the real nitty-gritty and say, okay, this is your overall process. Those are the levers that we can actually tackle, and that is your business case in the end.
Through this process, I mean, you've had it out there in the market less than a year. You're putting it in companies in less than a day. What lessons have you learned?
There are multiple. One that comes to mind, for example, Owen, is that we connected to a forklift or a variety of forklifts. We basically plug into the power system of the forklift, right? And we realized that this power supply was always cut when the driver left the seat, because it was basically, he was closing the power loop. So we said, okay, we need a battery in there to at least have the chance to have 5 or 10 minutes of runtime, even though the vehicle is not providing us with power anymore. And those are basically the things that you just learn by being out in the field, implementing it on different kinds of forklifts, modern ones, old ones. That's just one example of the challenges that we realized afterwards, because we thought, okay, we can just plug into the power supply and then we will have power. But it's sometimes a little bit more complicated than that.
Sure.
I'll add to that with from looking at more from the kind of edge sensor point of view. Whenever you're developing a system like this, once you've got everything working and it's robust, it all comes down to edge case detection and fixing the edge cases without creating another problem later down the line. So what we were able to do very quickly, and this is actually just good agile, innovative product development, is SYNAOS were running our systems for, they've done millions and millions of meters of testing for us, and we've been able to see the results of that testing, see how well our system's performing, everything from how accurately are we actually positioning the system, and even going down to even lower things like how much memory are we consuming on that device? Is the processor getting too hot? Are there other things that might be creating problems? And of course, I'd be lying if I said that everything worked perfectly straight out of the box, but that's almost by design. Is we start with a system which we know it will provide a good solution, but we can tune it, and then we work with our customers to tune it over time. And that's really kind of what we've learned is actually the more stress test, the longer we run the systems for. We've had these running 24/7 for a very long time, and that really pushes our software to its absolute limits, and that's where we really find those edge cases, because for these types of systems, it doesn't matter if you work well 95% of the time. That is nowhere near good enough. You need to be 99.99% of the time to really add value to these types of operations, and that's something we've really been working very closely on finding those problems, solving them, and making sure that the system gets better and better every day.
As you learn these lessons and make improvements to the software and to the system, do you automatically do upgrades for your customers?
We can do over-the-air updates. We have a full device management behind it, so that we can also do over-the-air upgrades. And that was also definitely a learning from our side. So today you really have to have very short, effective innovation cycles, right? That means that you cannot bring a device to a customer, especially in the early stages, and say, okay, leave it as is. And we talk about 6 months about your experience. You have to be in a continuous integration, continuous development cycle with the customer, that you can make changes. He says today, okay, I have this problem, and tomorrow he has to have a fix on his device. And that's what's definitely something that helped us also from an architectural perspective, that we have those abilities within the system to make quick software updates. And the other thing is that where we also looked into very, very long is how can we handle the device from a security perspective, of course, right? So that nobody else than certified users can actually access this camera and so forth. And that was basically, after you have the technology running, you really have to think about, okay, what does it mean now in production? What does the customer want in the end? And then we had a lot of also like stuff that we had to work on from, like I said, security, over-the-air update, device management, and so forth. Those were all the last steps of the process, but important steps, I would say.
I'm curious, this is a big innovation for warehouse digitalization. I'm sure you would agree. That's why you're here. What do you guys think I want you both to answer this. What is the next big thing for digitalizing and optimizing warehouse processes?
When you talk to a lot of people in this space, they're especially ones who are moving towards automation and using kind of real-time location systems in their workflow, there's a word which is used a lot, and it's creating a lot of stress at the moment. Is the word interoperability. It's the ability to have as we see more products hit the market that do have spatial intelligence, the real challenge is these machines aren't actually able to communicate and share that spatial intelligence in a meaningful way. In fact, quite often they just can't. It's black box. I call them spatial silos. So you might have your pallet moving robot, your stock tracking drone, your warehouse workers AR headset. They all need to answer actually very similar questions. Where are they in that warehouse in real time? What are the objects around them? But they're all doing it in very separate and very different ways. And I see this interoperability is becoming more and more of a pain point for the end customers, because ultimately they don't want to have 16 different systems running, especially with a lot of these systems. You have to go and pre-map. You have to empty the entire floor before you build your maps, or you need to do a lot of post-processing. So I think the future of logistics is really having systems which are able to communicate that spatial intelligence in a way that they can share across not just the fleet of products, but across all of the products operating within that space. That's a huge advantage to all of the products, because the local information that warehouse pallet moving robot might have could be really useful for the AR headset on the person as well. And if they can share that information, then you just go to another level of optimization and being able to be more efficient. So that's really where I see this all going, I call it the universal language of spatial understanding. And coincidentally, that's where SLAMcore's visual-based approach, but that's where we are looking to really build this out, because vision is the key solution to solving this universal problem of spatial intelligence.
Toby, what do you think is the next big thing?
I think Owen is absolutely right. He basically touched the two main points that we are also seeing for the warehouse of the future. The one thing is the integration capability. So you will have to make sure that your mobile robot and your forklift can operate within the same facility, and that you make sure that both of them are getting the information that they need when they need it. And that should happen through one platform. And that's basically what we are building with our other product, SYNA.OS Logistics. Based on that, of course, is you have to have very good decision making, who does what at which point of time, because you will have to orchestrate a whole fleet of different devices. And for that is basically our other core capability that we are bringing to the table, is basically our AI-based planning and scheduling, making sure that everybody is doing the most efficient task at that moment, depending on all the information that I get from the system. And then those two worlds actually come together. We're not the experts in data acquisition on the shop floor, for example, or in the warehouse. This is where SLAMcore comes in. But what we are really good is making sure that the data that is generated on the shop floor is integrated in one ecosystem, and then actually is monitored and optimized to the max capacity of the system. I believe that we see a lot of niche solutions at the moment in the shop floor. So, for example, what we talked about with Amazon, all this goods to person solutions, for example. This is just one area in the warehouse where there's actually a fence around it. Nobody can enter that. And it's one particular process that is digitized or even automated. But what about all the other processes, like the pallets that you have to bring in there, the pallets that go out there? Those are still heavily dependent on manual interactions, which can't be automated at the moment to a full extent, where you can bring, particularly in one or two use cases, robots in there. So, for example, to cover peak hours, you have 10 forklifts driving around. Okay, I know that around Christmas I have a peak hour. I also bring 3 robots in there. But how do I make sure that they are actually working efficiently, that they are not crashing into each other, that all are getting their orders, what they are supposed to do? Yeah, this is basically where those two worlds come together. SYNAOS is standing for integration and operation, and SLAMcore is taking care of the spatial intelligence data that we need to orchestrate our customer processes to the maximum.
As you both talked about these other things that are happening in the warehouse and throughout the facility, and we talk about this kind of stuff on this podcast all the time, such as the AI headsets, that people are using, and the AR, technology, and everything that's out there right now. So is there a way to integrate all those different technologies into one data system? Is that possible?
No. In my opinion, so for example, to give you an actual customer example that we have. This customer has a 50,000 square meter warehouse, and we are controlling the forklifts. There are different types of forklifts which are doing different processes in there. They have a multi-story pick tower where we are actually controlling the pickers, which tasks they are supposed to do. And of course, we are controlling, for example, the inventory management we do. And for example, also the automation, the fixed automation, like conveyor belts and so forth. They are all connected through our SYNA.OS logistics systems. But that is basically only giving you partial view of what's happening in the warehouse. We have to enrich all of this information to leverage the capabilities to the maximum by spatial information. Like, I have to know 20 centimeters exactly where my forklift is, so that I can actually realize other use cases, like, for example, introducing the first 1, 2, 3, 4 multiple robots into the system, that I can have full orchestration of all the resources that are driving around in such a warehouse. And for that, we need the data, and that is where SLAMcore comes in.
And maybe I'll pick up there, because
yes, please.
So in way in which that data is created, I think absolutely what SYNAOS do is have an amazing offering to bring that data together to create a unified space in which you can query and put jobs and understand what's going on in the warehouse and plan. We do still have a challenge where the way in which that data is created is quite fragmented. So there are very different types of systems running on the edge. So the HoloLens system is incredible, but it uses, I think, 6 cameras, multiple inertial sensors there. But then you look at some of the pallet moving robots using 2D LiDAR systems. Then you also have other systems which are just following magnetic strips on the floor, or looking at barcodes on the floor, much like the systems in Amazon. And this creates an overhead for the system in itself. And this is where I think really we have a really great coming together of our views of the world, because we believe that there should be a more centralized way in which you generate that data on the edge, and that's where vision really starts to come into its own. For us, we've been building this now for 5 years, and we launched our product only at the start of this year, and we already have about 100 companies now across about 40 different applications. So we have everything from lawnmower robots to drones to a robot which climbs along electric pylons and lays optical fiber behind it. And these are all using the same core visual-based system that we've developed, the same, very similar to the system that's running on the edge and we've been talking about today. And this really means that all of the systems are using the same edge framework and generating that data in a way which means actually you should be able to much more quickly create products into the future without having to start from scratch and build your own new robot or new pallet moving robot from yourself. And you can leverage benefits that we already have at the moment. And that's really where I think some of the real exciting ideas will come from. To be honest, I don't know what the next big breakthrough will be. What I'm certain is it will be enabled by having good spatial intelligence, because ultimately this technology allows machines to see the world the way in which humans do. So I think we haven't even started to scratch the surface of how exciting this is going to be.
Oh, it's incredibly exciting. It's really fun to talk about and think about and dream about. I mean, there's endless possibilities. We're getting to the end of our time, but I want to give you both a chance to have the last word and say a few things that maybe you wanted to talk about, but I wasn't smart enough to ask you about. So Toby, we'll let you go first and just kind of give us your final thoughts.
Yeah, I think that my final thoughts are that we are reaching a new milestone, I think, when it comes to warehouse digitization, because at the moment I see the predominant software tool in the warehouse industry is still Excel. And I think if we want to supercharge tomorrow's societal growth, we need more assistance and digitization in the warehouse. And whether it's SLAMcore, SYNAOS, or any other solution provider, I welcome them to join the party, basically. Please only make sure that you have open APIs, standardized APIs, because we have to reach the same level of interoperability that we have in the B2C world, also in the B2B world, I would say.
Good advice. Okay, Owen, what are your final thoughts?
I think this is something really, you touched on it earlier about what the timelines and what the future looks like in this space. But this the core technology of vision-based spatial intelligence actually was one of my co-founders, Professor Davison, actually showed the principles in 2003. So this isn't as far as a new concept. But one thing I think we've seen time and time with technology is we are quite bad at estimating the timelines, but also normally always underestimate the impact of this technology. And I think we're now at that point where this technology is now ready to be rolled out, and it's starting to have impact already. But I think, it's something which is ready for the prime time, and it's going to have a huge impact on the way in which we all live our lives across both logistics and every other, I think every corner of how we live our lives. I think that the impact's going to be profound and positive. I think both Toby and me are really keen to make sure that our technologies make the world a better place, and really I think this is starting to bear fruit now. So that's where I see this going, and I'm really excited to be a big part of this as well. So yeah, thanks.
Of course, Owen and Toby, thank you so much for being here. It's been great. Appreciate it.
Brilliant.
Thank you very much.
This brings us to the end of the show. Thank you so much for listening. Please do me a favor and subscribe, rate, and review the podcast on iTunes. If you have interesting information to share and want to contact me about being a guest on a future episode of this podcast, please send me an email at michelle@navigatecontent.com. You can also send me questions that I will have my expert guests answer for you on a future episode. And in the meantime, please check out my book series on modern manufacturing to read more than 30 real-world case studies about how global companies are using smart technology and innovation to build the factory of the future. All the links to the books and articles mentioned in this podcast are in the show notes. Have a great week, and please join me for the next episode of Factory of the Future.